Section 6, this is dealing with exponential functions, and what we're going to do is evaluate and graph exponential functions. We'll explain to you what that is right now. So an exponential function, excuse me, is just a function that takes the form like this. So we're used to linear functions that are like this, y equals mx plus b. Okay, so that's the form of a linear function. Exponential function is when you have something times something raised to an exponent. Okay, now what a has to be, it cannot be 0. B has to be greater than 0 and not equal to 1. And x has to be a real number. Okay, now the way that exponential functions look on a graph are, instead of being a straight line, like a linear function, they have a curvature to them. And they can go as you're going from left to right. So as x is getting bigger, they can go up, they can curve up, they can curve down. And what do we mean by curving up and curving down? Y is getting further away from our x-axis, and here's the same thing. Y is getting further away. Or here, from left to right, they can come from big and get closer to the x-axis. Now the difference is what that base is. When a base is a whole number, it's bigger. When it's a fraction, it gets smaller and closer to the x-axis. So it all depends on that, and whether or not it's negative. So you see here, this is 2x, this is negative 2x. Sorry, 2 to the x power, this is negative 2 to the x power. This is 1/2 to the x power, this is negative 1/2 to the x power. Now, how do we identify the difference between a linear and an exponential function? Well, linear functions have a common difference, and exponential functions have a common ratio. So that's the main difference, is that linear function, common difference, exponential function is a common ratio. So what we're looking for here is, if we look at the x values, they should go up at a common rate, right? +1, +1, +1. Okay, so when they do that, we look at the y values, and we look at what do they do. So right here it's, we subtract 2, here we subtract 6, and here we subtract 18. So because of that, we know there is not a common difference. So that's not the case. Okay? So if that's not the case, if it's not a common difference, is it a common ratio? So a common ratio, we're looking for either multiplication or division. Differences are addition and subtraction, and ratios are multiplication and division. Is there anything that you multiply these by in order to make the change? And the answer is yes. From -1 to -3, you multiply by 3. Same here. Multiply by 3, multiply by 3. So because of that, this is an exponential function. And the reason for that, it has a common ratio. Remember, again, ratio means you multiply or divide by something, the same thing every time. Okay? How about this one? Well, if you wanted to, you could make a chart, and you could just use, 1, 2, 3. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. You look, the x's are a common difference, and the y's are a common difference, +3 and +3. So because of that, we know that it is a linear function, because it's a common difference. The other reason we know is because it is in the form y equals mx plus b, where b is 0 in this case. It is not in the form of y equals a times b to the x. So this is exponential, this is linear, and so part B is in that form, and so because of that, we're looking at a linear function. All right, so you try on this one real quick. Okay, if we look at our x's, we want to make sure +1, +1, +1. So it's going up by the same rate each time. And the reason you have to make sure that if your x's are jumping all around, you can't really look at your y's very accurately. Okay, what do you do in order to get from -1 to 1? Well, one thing is, let's see, you can add 2. To get from 1 to 3, you add 2. To get from 3 to 5, you add 2. So they have the common difference, and therefore that one's linear. Here, this one's pretty easy. It's in the form of a times b to the x. So therefore, this one is an exponential. Oops. Yeah. Suppose you have 30 flower beets, and they are left undisturbed in a warehouse bin. The beetle population doubles each week. The function 30 times 2 to the x gives a population after x weeks. How many beetles will there be after 56 days? So the tricky part about this is they ask in 56 days, but x represents weeks. So the first thing we have to figure out is how many weeks is 56 days. To do that, we divide by 7 days in a week, and we get x is 8. Now, to solve that, we're going to plug in 8 for x, and we have 30 times 2 to the 8th. 2 to the 8th is 256, and 30 times 256 is 7,680 beetles after 56 days. Now, how about graphing? Graphing, this is not that much different than graphing a linear equation, except it's a little bit trickier to do it without a chart, and so I recommend, or without a table, and so I recommend a table. Okay, a good idea for these is to make sure that you start on both sides of the 0, so you get values on both sides. So we're going to go -2, -1, 0, 1, and 2. All right, and so now we're just plugging this in. So what is 2 to the -2nd power times 3? Well, 2 to the -2nd, if you think about this, 2 to the -2nd turns into 1 over 2 squared, and that's 1/4. And then 1/4 times 3 is 3/4. Okay? -1, that's going to be 3/2. 0, 3 to the 0 power is 0. Sorry, 2 to the 0 power is 1. 3 times 1 is 3. 2 to the first power is 2. 3 times 2 is 6. 2 squared is 4. 3 times 4 is 12. All right, and so now we're going to graph these. So -2, 3/4. You got to be pretty accurate. Right about there. -1 and 3/2. 3/2 is 1.5 right there. 0 is 3. 1 is 6. And 2 is 12, which is going to be right about there. And that you have to kind of estimate. And this goes right along the x-axis. And the reason I know that is there is no number that's going to turn y negative. There is no way that this is going to ever get into the negative. I don't care how far over you go. It's always going to be a positive value. And eventually it's going to get so close to 0 that it just basically hugs the line. All right. Graphing is something that on the calculators, that's something that we will look at in class. And so we're not going to really talk about that right now. that about does it for this chapter on what we're going to show you on the video. We can show you this other stuff in class.